is going to be an introduction into kind of like the core of geometry, which is proofs. So today we're going to talk about patterns and inductive reasoning. A lot of what we're talking about today is, okay, hey, I recognize this. Here's what I'm observing. Let me use that to kind of make a guess about what's going to happen. So, patterns and inductive reasoning. Inductive reasoning is one of the words that you should have put in your vocabulary. Inductive reasoning is just what I just said. It's, hey, I observe this. Now look at this pattern, and here's what I see, okay? When I see that, here's what it makes me think is going to happen next. Okay, it's just kind of an observation, using that observation to kind of go forward with that. So I could maybe use inductive reasoning with these two patterns that I have here. So first of all, I have a little typo here. There's not really a good pattern here unless I change that 3, sorry, to a 6. My goodness. Okay, to a 6. There we go. That would be a little bit better. So what I can do is I can look at this pattern, and maybe I can say, okay, this is what I'm observing. From 6, 9, 12, 15. What are we observing here? Yeah, it looks like we're just adding 3, right? 6 plus 3, 9 plus 3, 12 plus 3. If we wanted to be a little more specific, we could say, well, what you're doing is you are going to add 3 to the previous term. Yeah, to get to the next term, add 3 to the previous term. So sometimes our patterns are going to be numbers, sometimes they'll be letters, sometimes it'll be shapes. So I have these 3 shapes here. Well, let's see if we can figure out what we're observing. So I've got this circle that has a triangle in it, and then I have a circle that has a square in it, and then I have a circle that has a pentagon in it. So it looks like every time there's a circle, but what's changing is what's inside this circle. What are you observing here? Yeah, you're adding an extra side. So a triangle has 3 sides, a square has 4 sides, pentagon has 5 sides. So the next, okay, hexagon would have 6 sides. So inside my circle, okay, right? That's a terrible hexagon, but okay, you would add an extra side. So if I wanted to put that in words, I could say the shape inside adds a side. The shape inside adds a side. So the next shape would have 7 sides and then 8 sides and on from there. So that's inductive reasoning, just observing something. Some patterns are really easy to see. Those ones were pretty simple ones. Other ones may take a little bit of thought to do. Now what we can do with this inductive reasoning, with these observations that we make, is we can make what's called a conjecture. A conjecture, kind of simply put, it's just a guess. It's here's what I observe, here's what I think is going to happen. Okay? So using your observation to then go forward and make a guess. Okay? Now you can make a guess and maybe it's not true. So not all conjectures are true. We'll talk about that here in just a minute. So if I look at these shapes here, I have this pattern. I've got a circle that has 1 diameter. I have a circle that has 2 diameters, a circle that has 3 diameters. What I want to do is I want to look at the pattern, and I want to see if I can make a conjecture about the number of regions. So 2 regions, 4 regions, 6 regions. The number of regions that would be created if I had 20 diameters. So the first thing I need to do is maybe look at my pattern, see if I can figure out, well, what is, look at my sequence, sorry, and see if I can maybe see what the pattern is. So what I'm looking for is the relationship between the number of diameters and then how many regions it creates. So this one has 1 diameter, and it creates how many regions? 2 regions. The next shape has 2 diameters, which creates how many regions? 4. Okay, that third shape has 3 diameters, and it creates how many regions? 6. Okay, what do you think the pattern is? Yeah, it's just twice the number. So we could say Each circle has twice the number of regions as diameters. Twice the number of regions as diameters. So if there were 20 diameters, how many regions do you think there would be? Yeah, 40 regions. Now, I'm not actually drawing it, so maybe I don't know like for sure. I haven't like proved it's absolutely true, but it's a conjecture, it's a guess. From what I observe, here's what I think is going to happen. Okay? Now, sometimes whenever we're making a conjecture, we're just looking at a pattern and saying, okay, here's what I see happening, here's what I think is going to happen on the 20th shape. Sometimes I might be looking at a numbered sequence, but sometimes we may have to gather our own data. So, for example, if I want to make a conjecture about the sum of the first 30 even numbers, okay, what might be helpful, because I don't want to actually like write out the first 30 even numbers and add them together. That's one thing you could do. But the point here is we're making a guess. We don't want to actually do it. We want to look at a pattern and say, okay, well, maybe I don't want to list out the first 30 even numbers, but maybe we start by listing out the first even number, and then 2 even numbers, and 3 even numbers, and 4 even numbers, and see if maybe there's a pattern. So that's exactly what we're going to do here. So let's say we start with just one term. Okay, so this would be like the first term in the sequence. Well, we're talking about the sum of even numbers. So the first even number would just be 2, and the sum of the first even number is just 2. Okay. If I'm talking about 2 terms, that would be 2, and the next even number would be 4. So the sum of the first 2 even numbers would be 6. And we could keep going. We could do, okay, the sum of the first 3 even numbers would be 2 plus 4 plus 6, which would be 12, right? And then we could say, okay, if I do the 4, 2 plus 4 plus 6 plus 8, add all this together, you should get 20. And we could keep going, but the point is I don't want to list out all the way to 30. What I want to do is I want to look at a pattern, and this one, I will warn you guys, is a little harder to see than the ones you'll have in your homework. The ones in your homework are going to be easier to make a conjecture about. This one, I'm not going to lie to you, I had to look in the book and get help on this one because I didn't see it this way. I could probably come up with the first 30 even numbers. How would you get the next number? Other than taking 2, right? What would you do?
It's going up 2 more than it did last time.
It's going up, that's a good way to think about it. It's going up 2 more than it did last time. So this went up 8, the next one's going to go up 10, and then 12. Exactly, that's exactly right. But I have to come up with a way to come up with, without actually finding it. I'm going to give you guys a second to think about it, but like I said, even I didn't really see this. Now that I know what the answer is, I'm like, oh, okay, I can see how you come up with that. Can anybody think of a way, just like, saying, oh, here's the formula, here's what you do to come up with some of the first 30 even numbers? Okay, I'm going to tell you what it is, and then I'll kind of explain where it comes from. Another way I could get 2 is I could take 1 times 2. And to get 6, I could take 2 times 3. And to get 12, I could take 3 times 4. And 4 times 5. Does that work? Why that happens is this would be just 2 one time, okay? This is 2, and then 2 more 2s, right? And then that's this, plus 2, 2, 2. And then that's this, which is the 3, right? Plus another set of them. That's where it comes from, okay? So, like I said, the one in your homework is going to be easier to see than that, okay? But if I wanted to use that pattern, how would I find the sum of the first 30 even numbers? Yes, so it'd be 30 times 31, which is crazy that you can come up with it that way. But it would be 930, which you really wouldn't want to add those all up anyway. Like I said, one more time, the one on your homework is going to be easier to see than that one, but kind of interesting where that comes from. Okay? Questions on that? Okay, now, like I said, I can make a conjecture. I can say, well, I mean, the book told me this, so I'm pretty sure it's right, but maybe it was wrong, okay? I can make a conjecture that it's not necessarily right. So if you want to prove that a conjecture is false, okay, so we can assume that a conjecture is true, but if you're like, no, that conjecture is false, all you have to do is give me one counterexample. And a counterexample, it's just an example that says, no, that's not right. So maybe I'm like, you know what, guys, I'm a genius. You guys already know that. But I'm a genius, and I decide that, here's the thing, you can connect any 3 points, to make a triangle. That's my conjecture I'm going to make. You can connect any 3 points to make a triangle, and I think that's true. Because everything that I've seen, right, you can make 3 points, boom, 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 there's my triangle. I think it's true. If it's false, all you have to do is give me one example that shows that it doesn't work. It just has to not work one time. It can work every other time, but if there's one time that it doesn't work, that conjecture is false. Can you guys come up with a counterexample? Yeah, what if they're in a straight line? Yeah, if I put the 3 dots in a straight line, I can't form a triangle. So we would go ahead and say that that conjecture is false. You just need one counterexample. Okay, questions on any of that? Okay, on Friday, we should have set up in your notebook that the table of contents was on page 17, which means this needs to be glued into page 19. And we want to go back to our table of contents and make sure we include this. This is 2.1, which is patterns and inductive reasoning. So get that glued in, get your table of contents filled out. All right, so most of what we're doing today is looking at a sequence, determining the pattern, sometimes using that pattern to then go ahead and make a guess. So that's the first thing we're going to do is we're going to find a pattern for each sequence, use the pattern to show the next 2 terms. Now in Algebra 1, we learned about 2 different types of sequences. We talked about geometric sequences, which I know you guys remember exactly what these are, but a geometric sequence is where you get from one term to the next by adding or subtracting. And then later on, we learned about geometric sequences, which is where you get from one term to the next by multiplying and dividing. And I know I told my students last year that yes, there are sequences that are neither arithmetic or geometric, that are still sequences, they just don't fall under those 2 categories. But those were the 2 that we really concentrated on last year. Today, we may see sequences that aren't arithmetic, they're not geometric. I can't really come up with a formula just to plug numbers in and find the answer, but I can identify the pattern. So we may see some of those today. So our first pattern, our first sequence is going to be 3, 9, 27, 81, and so on. So first thing we want to do is we want to find a pattern. So from 3 to 9, 9 to 27, 27 to 81, multiply by 3. So if we want to be super specific, we could say multiply the previous term by 3. Multiply by 3. Multiply the previous term by 3. So to find the next 2 terms, I would take 81 times 3, which is 243, just off the top of my head. Some of those math facts I know. And then 243 times 3 should give me 729. Once again, just, off the top of my head. Just did it in my head. Just kidding. Okay. All right. And number 2, what about this one? This one says 1, -2, 3, -4, by the pattern. Do what? Okay, so it's a positive and then a negative, a positive and a negative. So I know what the signs are going to be. And then number-wise, Gabby? That's an excellent thing to notice. You guys see that? All the odd numbers are positive. All the even numbers are negative. Okay? Really, for things like this, I mean, however you want to describe the pattern, I think we all know what the pattern is, but putting it into words can be a little more challenging. So what I said is I said each term is the next opposite integer. Each term is the next, but opposite integer. So after positive 5 would be what? Negative 6. And after negative 6 would be positive 7. So this is an example of one that you couldn't come up with a formula for this, like just to plug numbers in. But there is a pattern I can identify. Okay? Next, going to kind of do the same thing. Use the sequence in inductive reasoning to make a conjecture. So the sequence that we're going to look at is R, W, B, R, W, and so on. Okay, so that's my sequence. We can kind of think about what the pattern is, maybe think about where it's going. But what I want to do is I want to make a conjecture about this. I want to know what is the 21st term.
Could you please send Gabby Graham to the office for an appointment, please?
Okay, she's on her way.
Thank you.
Okay, so I see my sequence RWB, RW. I can kind of develop that. What do we think the pattern is? If you were to guess. RWB, 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 RWB. And I could list it out to the 21st term, but how am I going to know? Or I guess, what do you think? What do you think the 21st term would be? What do you think? A B. What's making you think it would be a B? So 21 is divisible by 3, but why is the 3 important? Because what? Because RWB. RWB. The third term is a B. The sixth term is going to be a B. The ninth term is going to be a B, right? Every third term is going to be a B. Yeah, exactly. Now, once again, this is a conjecture. I don't know, like, for sure. I'm pretty sure. But just a conjecture. Okay? All right, what if I want to make a conjecture about this? The sum of the first 100 positive odd numbers. The sum of the first 100 positive odd numbers. So we did kind of the even numbers and saw that pattern. The odd numbers actually, surprisingly, are easier to come up with. Okay? Now this is one where, I mean, I definitely don't want to take 1, 3, 5, all the way up to 1. Oh my gosh, that would take forever, right? Adding up all the odd numbers. So this is where maybe we collect some data. Maybe we list out some of the sums of the first positive odd numbers, and we can see a pattern. So if I have one term, the first term in this sequence would just have one number, and the sum of 1, just 1. Okay? The second term in my sequence would have 2 terms. The sum of 1 and 3, right? Which would be 4. Okay, the third term would be 1 plus 3 plus 5, which would be 9, right? The fourth term would be numbers, 1, 3, 5, 9, which would be 16. You may start to see a pattern developing, but an easy way, I mean, we know what we'd add next. What number would you add next? What's the next number we'd add? Oh, I should add 7, shouldn't I? Oh, goodness, what you gonna stop me? 7, I had 9 actually, right? Okay, sorry. That doesn't give you 16, does it? Okay, so if you add 7, you get 16, then you would add 9, and you get 25. Okay, now look at those numbers. 1, 4, 9, 16, 25. Those are interesting numbers. They can all be square rooted, right? What do you think the next number might be without actually finding it? 36. And then after that? So you guys think the next number would be 36 and then? 49. You guys are exactly right. How are you getting that? Yeah. You square the number of terms. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So the first 100 positive odd numbers would be 100 squared. Which would be 10,000. We for sure don't want to add that up. Amazing, right? How smart you guys are. Okay, last couple of examples here. Remember, I can make a conjecture. I think that's what I'm observing. I'm not like 100% sure without actually finding my answer, but I can make a conjecture. And if you want to prove me false, if you want to say, yeah, that's not right, you have to give me one counterexample. There may be more than that, but you have to give me at least one counterexample. So maybe I'm like, hey guys, I'm a genius. You guys already know that, but I'm like, hey, I got something. I got a conjecture for you. Here's what I've observed. Watch this, okay? This is what I wrote down. Okay. If the name of a month, starts with J. Okay, if the name of the month starts with J, it's a summer month. If the name of a month starts with J, it's a summer month. Because June and July, right? No! Why? January, right? January screwed it all up. All you have to do is give me one. If there's more than one, great, but you gotta give me just one example. Those are my conjecture. Darn, I guess I'm not as smart as I thought I was. Okay, and then last one, find the pattern for each sequence. Kind of the same thing. May or may not be an arithmetic or geometric sequence. And then see if we can find the next two terms. So this one says 1, 2, 5, 6, 9, and so on. 1, 2, 5, 6, 9. What do we think the pattern is?
Add 1, add 3.
Yeah, exactly. Add 1, and then add 3. Add 1, and then add 3. So the next term would be 10, and then 13. Very good. Very good. You guys have questions on any of that?